This video is all about showing you how to solve trig derivative problems. Make sure you like the video, share with a friend, and be sure to subscribe. To solve trig derivative problems, the first thing you need to know is what are the trig derivatives? So if you don't already have these down, you don't know your trig derivatives, make sure you write them down, put them in your notes, put them on a special piece of paper so you won't lose it. I recommend a different color sheet of paper, like a colored paper that you will easily find in your notes. I recommend that you have another notebook just for some of the more important rules that you're going to need to remember in solving these math problems. If you don't know how to find these trig derivatives, in my previous video, I showed you how to do that. Make sure you check it out. Get these written down, and we're going to move on to the examples. Let's go. Pause the video if you need to. The first problem is they want us to find the derivative of this function. We have to use the quotient rule, which I know it as low d high minus high d low all over low low. If you're not familiar with that, you can check out my other video that talks all about the derivative rules. So we're going to use low d high minus high d low all over low low. The first thing you need to identify is what is your high piece, what is your low piece. I'm going to rewrite it to write it out for us easier. So y equals sine x 1 plus cosine x. This piece is my high piece. This is my low piece. So the first thing I'm going to do is the derivative of my high piece is cosine x. The derivative of my low piece, well, the derivative of 1 is 0. Derivative of cosine x is negative sine x. I write these out first, so now all I have to do is go ahead and plug those in to the quotient rule. So the derivative equals low, which is 1 plus cosine x, d high, which is the derivative of my high piece, which we already wrote down was cosine x. See, it's nice and easy, you're just plugging it in. Minus your high piece, which is sine x, times the derivative of my low, which is negative sine x, all over low low. So the low piece is squared because low low means you're needing it twice. All right. Now I'm just going to go through and simplify my numerator. If you didn't know this already about calculus, calculus is a lot of algebra. So my y prime equals, now I'm just going to distribute in my numerator. So we've got cosine x plus cosine squared x minus, oh, I have a minus here, but I have a negative sine x. So this makes this a plus sine squared x all over 1 plus cosine x. The whole quantity is squared. Now, hopefully you're getting a little bit excited because you should see something in the numerator and going, oh, I recognize that. Oh, I know what that is, right? Hopefully you see this piece right here. Cosine squared x plus sine squared x equals? Yes, it equals 1. So this whole piece right here just equals 1. Now, let's see what we have left. So in the numerator, y prime equals cosine x plus, this whole piece went to 1, all over 1 plus cosine x quantity squared. Now we're going to do a little trick here. We're going to take that denominator, we're going to separate it apart, and then hopefully you should see why. So our numerator is cosine x plus 1 all over, and I'm going to write the denominator in 2 pieces. And hopefully you see that this piece will be a 1. So what you're left with is 1 in the numerator all over 1 plus cosine x. All right, next we have y equals sine x over x. We're going to find the derivative. So f prime equals, again, quotient rule, low d high minus high d low all over low low, right? So this is my high piece, this is my low piece. Derivative of my high piece is cosine x. Derivative of my low piece is 1. Well, doesn't that make life easy? So low x times derivative of my high, cosine x, minus my high piece, times derivative of my low piece, all over low. So f prime equals, now we're just simplifying the numerator, so x cosine x minus sine x all over x squared. And as you look at this answer, it looks kind of ugly, but guess what? There's nothing else we can do. No other simplification can be done. So guess what? You're done. This is the derivative for that problem. All right, finally we have a problem with not the quotient rule, but guess which rule we do have? The product rule, right? So I'm going to write f and g above those two pieces because this is going to help us solve our product rule. In a thought bubble, I'm going to put their derivatives. This way it'll make it easier. We're just plugging in once we do their derivative. So the derivative of x cubed is 3x squared. And then the derivative of sine x is cosine x. Now I'm going to go ahead and write out the product rule. Watch. So we've got f prime of x equals, so the product rule, derivative of the first times the second plus the first times derivative of the second. That is just this part here in pink. So let's do that. Derivative of the first piece, so we're just plugging in, 3x squared times the second, sine x, plus the first piece, x cubed, times derivative of the second is cosine x. So this is just that first piece right there. Now, let's go ahead and take this derivative, and I'll do this in black to show you that we're doing this piece next. So this minus sign comes right down here, minus 5 cosine x. So the 5 stays, comes along for the ride. Derivative of cosine, negative sine x. Now let's go through and just multiply this out and clean it up. This piece is just going to say 3x squared sine x plus x cubed cosine x. Now negative times a negative plus 5 sine x. There is one more step you can do because this probably would not be the final answer in the back of your book. Notice that this piece and this piece both share a sine x. So we can pull a sine x out of both of those pieces. So let me show you what that would look like. So f prime of x equals, we're going to take this 3x squared, right, plus a 5 times sine x, plus, now you just have this other part left, the x cubed cosine x. And this then would be your final answer. All right, so now we're going to do another product rule problem. So we have secant x times tangent x. So this is my f part, this is my g part. So f prime equals, remember it's f prime times g plus fg prime. I always like to write out the rule because then I'm just plugging in. It makes it easier. So f prime, all right, what's the derivative of secant x? Do you remember? Derivative is secant x tangent x. Very good. And then we just write down tangent x plus the f piece is secant x times derivative of g, derivative of tangent. Do you remember what it is? Derivative of tangent, secant squared x. So now we're just going to simplify, and you've got secant x times tangent squared x, right? Plus, and how many do we have over here? We've got 3, secant cubed x. And there you go. All right, now we're going to take the derivative and also find the equation of a tangent line. So the derivative, y prime equals square root of 2, that guy's going to stay. Derivative of cosine x is negative sine x. So I'm just going to rewrite this with my negative sign out front. So that's our derivative. And where does the derivative go in our equation of the tangent line? Hopefully you know. This guy is going to be your slope. Now that we have the derivative, we need to write the equation of a line. Y minus y1 equals m times x minus x1. And at this point, we're just going to be plugging in. Since we have our x value, we just need to go back to the original equation and find our y value. So the equation was y equals square root of 2 cosine x. And they wanted it when x equaled pi over 4. So that's going to equal square root of 2 cosine of pi over 4. And hopefully if you remember your triangles, cosine is 1 over the square root of 2. So the square root of 2 times 1 over the square root of 2, oh, doesn't that work out just peachy keen and nice for us, is 1. So this is our y value. So when we come back over here, we have y minus 1 equals, I'm going to leave the slope out for a minute. Well, actually, you know what? The slope is this piece right here. So I'm just going to put negative square root of 2 sine x, and then we'll plug him in just a minute. And then we have x minus pi over 4, because that's what we had. That's the x value they gave us. Now I'm going to go ahead and find what this guy is, negative square root of 2 times sine of pi over 4. And again, coming over here, if you look at your triangle, your sine of pi over 4 is 1 over the square root of 2 as well. So negative 2 times 1 over the square root of 2. Well, doesn't that work out just peachy keen to be negative 1? So our full equation, are you ready? Y minus 1 equals negative 1 times x minus pi over 4. This is your equation of the tangent line of that function at x equals pi over 4. We have another equation of the tangent line problem. So anytime you need an equation of the tangent line, hopefully you should just go ahead and write down the equation for a line, which is y minus y1 equals m times x minus x1. And in this case, they already gave us our x value, so I can go ahead and plug that piece in. And now I'm going to go ahead and solve for my y value. So in this problem, I'm going to go ahead and break this up here. We're going to write y equals, we've got 4 plus cotangent at pi over 2 minus 2 times cosecant at pi over 2. So hopefully you remember where pi over 2 is. So on your circle, pi over 2 is up here, and this coordinate is our x value is 0, our y value is 1. So y equals 4 plus, now cotangent is cosine over sine. Our cosine value is our x value, and our x value at pi over 2 is 0. 0 divided by 1, we can do that, and that would be 0. So this would be cotangent of pi over 2 is 0 minus 2 times, now we have to do cosecant at pi over 2, and cosecant is 1 over sine, and our sine value is the y value, and our y value at pi over 2 is 1. So 1 over 1, 1. So times 1. So here we have y equals 4 minus 2 is 2. So I can go ahead and plug that guy in right there. Now our slope again of the tangent line, derivative, derivative, right? Hopefully every time you hear slope, you hear derivative in your mind. So now I need to find the derivative of that function and plug in pi over 2. Are you ready? I'm going to go ahead and rewrite our function. So let's put a line here. Y equals 4 plus cotangent of x minus 2 times cosecant of x. Let's find the derivative. Y prime. Derivative of 4 is going to be 0. The derivative of cotangent, negative cosecant squared x minus 2. Now you have to multiply by the derivative of cosecant x. Do you remember what it is? It's negative cosecant x cotangent x. So y prime equals negative cosecant squared at pi over 2 minus, minus and a minus, that's going to be plus 2 cosecant of pi over 2 times cotangent of pi over 2. Now, from solving our y values, hopefully you remember what these values were. Cosecant at pi over 2 was 1. Negative 1, and that will be squared. Plus 2 times 1 times, and cotangent of pi over 2 was 0. In this piece over here, it was cosecant squared. It was cosecant of pi over 2 squared. So this part is like this, and this is why that negative is still going to stay there. And this part's going to drop out because of your 0. So your slope, your derivative, is negative 1. Now we can go back up and plug that derivative into our slope formula. And now you have the equation of the tangent line at pi over 2. I hope these examples help you solve trig derivative problems. If there's any specific problems or topics you want me to cover, make sure you drop it in the comments below. Please like and subscribe and share with your friends. I'm just gonna erase this. Whoa, that's not how I erase things. For real, yo.